I've got 4 of these different boards with outlets on it, and they're wired in different ways. And I want to do some experiments and draw some conclusions and all that. So let's see. Let me go ahead and get 2 100 watt bulbs. These are 100 watt bulbs, and we're gonna put these in and. Okay, and we'll plug them in, and okay, and things to note is that they're both equally bright. Now, when I unplug one, notice the other one stays lit. What does that mean about how these are wired?
Are they running in parallel?
They're wired in parallel. Good. Okay. So we've got my 120 volt outlet, and we have 1, and we have 2. So 1 and 2. When I unplug 2, okay, number 1 still has a complete circuit for electricity to be drawn. Okay. Now what I want to do is substitute bulb number 2. I'm going to substitute it for a 40 watt bulb. Okay, so this would be a 40 watt bulb. And one thing I forgot to mention, of course, this is how the outlets in your house are wired. They're wired in parallel. Otherwise, if you unplugged your phone charger, your PlayStation would turn off. Okay, it would not be a good situation. If you unplugged your hairdryer, your refrigerator would turn off. Okay, so that would not be a good situation. Okay, so so here I've got a 100 watt bulb and I've got a 40 watt bulb here. Which one of these is going to be brighter?
40 watt?
Okay, let's try it. So 100 watt, 40 watt. Okay, I'd say the 100 watt bulb is brighter. Okay, it's brighter. And now both of these bulbs are getting the same voltage. They're both receiving 120 volts. So let's say number 1 and 2. Okay, so this is my 100 watt bulb and this is my 40 watt bulb. Okay, they're both getting the same voltage. Why is the 100 watt light bulb brighter? What must it be getting more of?
Current?
It must be getting more current. Okay, so there is more current, okay, going through the 100 watt light bulb than the 40 watt light bulb. What does that say about the resistance?
It's higher.
More resistance gives me more current?
Yeah. It's lower.
Yeah, the other way.
There we go, the other way. Okay, that means that the 100 watt light bulb must have less resistance. So if I were to redraw the 40 watt light bulb, I might draw it as a much longer filament and the 40 watt light bulb as a smaller filament. Okay, so the 40 watt light bulb has more resistance than the 100 watt light bulb. All
Oh, I
right.
get, that's where I get messed up. For some reason, I was correlating resistance as a unit in watts, but it's actually power, so yeah.
Power is what measures
That's-
brightness.
That's what got me.
I was the opposite.
Okay, so let me go ahead and switch to my series board. All right. So this board is in series. So it's hard to tell from the wiring on the back, but it is in series. This is not how your outlets are wired at home. Otherwise, as we mentioned before, lots of curious things would happen. Okay, so what I'm going to do is I'm going to plug in a 100 watt light bulb and I'm going to plug in a 100 watt light bulb. Let's say this is number 1 and this is number 2. So okay, so current is flowing this way. Because the positive side of the battery is the larger node. Now, which light bulb is going to be brighter? Number 1, number 2, or would it be the same?
Same.
Number one.
Okay, let's plug it in and find out. They both look pretty much the same, don't they? Okay. And that's because, just because number 1's up front doesn't mean it takes more voltage. Each one of these bulbs has the same resistance, which means it takes the same share of voltage. These bulbs are the same, which means this bulb is taking 60 volts, or is causing a 60 volt drop, and this bulb is causing a 60 volt drop. Yeah, Grady?
Isn't it like if they're like they can essentially, if they're the same resistance on both the bulbs, you can basically replace them with a singular resistor in a sense?
You can.
It's the same, yeah.
You can. Even if they're not the same, you can replace them as a single resistor. It's called the equivalent resistance. And you know, that's something that you'll be doing in mixed series and parallel with different resistances and different combinations and all that. So that's a skill that you need to acquire to be successful. Okay. So so let's see. So we've got my 100 watt light bulb and my 40 watt light bulb. And of course, notice when I unplug the first light bulb, that one goes out. What happens if I unplug the second one? Will it still go out?
Yes.
Yeah, it'll still go out. Okay. All right. What I want to do is I'm going to switch the 100 watt light bulb with a 40 watt light bulb. Okay. So now remember, which of these has the greater resistance, the 100 or the 40 watt light bulb?
100.
Close.
40.
The 40. Okay. So the 100 watt light bulb and then the 40 watt light bulb. Okay. 40 watt light bulb. Now when I plug this in, which one's going to be brighter in a series circuit?
Neither.
Okay, I got one neither. Any other?
I'm gonna say the 100 watt.
Yeah, I'm gonna,
Okay.
well, I don't know.
40 watt.
I was close.
You were close. Okay. Now we know this one is lit. It's just very dim because if I unplug it, it goes out. Okay. So why is the 40 watt so much brighter than the 100 watt? Well, the 40 watt has a higher resistance, which means it's taking a greater share of the voltage. They both have the same current. But V equals IR. They have the same I. This one has a bigger R, so therefore it has the bigger V. V equals IR. Okay. So this is exactly opposite what happens in a parallel circuit. So which makes it the kind of question that physics teachers like to ask. Okay, because it's counterintuitive, and it tests whether or not you get what's going on. Okay, but does that make sense? At least, okay. All right. So that's my series board. Let me switch. I'm going to switch back to all 100s, and let's get out my mixed series parallel board. All right. Okay, so this one is like so. All right. So this one and these are all 100 watt bulbs that I'm going to put in, okay? So first off, what do you think about the relative brightness of these bulbs? Is one bulb going to be brighter than the others, or should they all be about the same? Or should two bulbs be brighter than
One
one?
will be
Yeah.
brighter than 2 and 3.
Okay, we think one will be brighter than 2 and 3. Is that because it's first?
It's because it's the one not in parallel, it's the one in series.
Okay. And that is true. These are lit. They're just very, very dim. Okay, these are lit. Why does this one being in series make it brighter? Okay, so if it's got more power, that means it's either taking a greater voltage drop or a greater current. So why would this one be brighter?
Takes more current.
Okay, it has more current because the current going through this bulb is split between these two. So these two, it's halved. Okay, so twice the current's going through this bulb than it is these two bulbs. All right. So now let's say what's going to happen when I unplug bulb number 2. Okay.
Nothing.
All right. I'm going to unplug bulb 2.
Three will
What
get
happens?
brighter.
What's that?
3 will get brighter.
3 will get brighter. Okay. And 3 did get brighter.
And one
Okay.
got dimmer.
But 1 got dimmer. Okay. So first off, why did 3 get brighter? Well, because it's no longer sharing its current with 2.
It's now basically just a big series.
It's just a series circuit. That's right. Okay. Why did 1 get dimmer? Well, when I disconnected this, I increased the resistance of this part of the circuit. Okay. When you add resistors in parallel, the resistance goes down. When you take a resistor out in parallel, the resistance goes up. So the resistance of this circuit went up, meaning it slowed the current overall going down. So now I've got less current flowing through number 1. Okay, but 3 did go up in brightness because it's all right. All right. Now, what's going to happen when I take out bulb number 1?
They're all gonna go out.
There we go. They all go out.
Whoa.
All right.
It's like magic.
Isn't it? Oh, that's hot, like magic. All right. Is there anything else I wanted to do with this one? I don't think so. All right. And for my last board.
For my last trick.
My final trick, yes. What I want us to do is try to figure out how we think this thing is wired. Okay? How this thing is wired. Let's plug in all 100-watt light bulbs. Okay, we're down there. Okay. Now, so notice that number 1 is brighter than 2 and 3. All right. If I unplug number 3, okay, 2 goes out, 100 stays lit. Okay. If I unplug number 2, 3 goes out, 100 stays lit. Okay. If I unplug number 1, nothing happens.
Number 1 is in parallel and 2 and 3 are together in series.
That's right.
Does that make sense, or do I need to draw that?
I think I got what you mean. So what we have is we've got our battery. Okay. We've got, let's see,
That's 1.
1. 3. Okay. When I unplug 1, there's no change to 2 and 3. It's like that's not even there. Okay. If I unplug the 100, If I unplug 2, 3 goes out, okay? If I unplug 3, 2 goes out. Okay. Why is 2 and 3 dimmer in terms of current voltage and resistance?
Because 2 and 3 have to share the current. They're getting the same current as 1, but they have to share it between each other.
Isn't it?
That's
Isn't it the same
backwards.
current throughout both
That's wrong.
resistors?
Yeah, I take it back.
Yeah.
These two and 3 have the same current as each other.
It's the resistance is higher, my bad.
The resistance of this branch is higher than the resistance of this branch, which means I'm getting less current flowing through this branch.
Once I said it, I knew I was wrong.
That's okay. All right, good. So this concludes our demonstration.